Hi, everyone. Welcome to our Women in STEM panel. My name is Rona, and I'll be moderating the panel today. Our panelists are Molly Mcshane from Instrumental Inc., Marianne Mehta from Boeing, and Vicky Wang from Snap.com. And now I'll let them formally introduce themselves in that order. The panel today.
Hey, I'm Molly Mcshane. I'm a solutions architect at Instrumental Inc., which is a small startup, about 50 people. And my background's in mechanical engineering. Previous to this job, I worked as a product design engineer at Google, designing laptops and tablets. And today in my role, I do we basically built a manufacturing optimization platform. So helping a lot of other people find and fix issues in manufacturing. And my role is still being a mechanical engineer, but also interfacing with customers and doing a lot of other little odds and ends at a startup. So helping a lot of other people.
I'm Marianne Mata. I work for Boeing in Seal Beach, and I'm a mechanical engineer. I hired into Boeing from college and worked on the space side of Boeing. I hired into the space shuttle program and started out on fuel cells and cryogenic reactants, and have since worked other power systems for Boeing for aircraft, and am currently I am working on propulsion systems for satellites. Started out on fuel cells and cryogenic reactants.
Hi, I'm Victoria Wang. I work at Snapchat. I work in the Snap Labs, which is responsible for Snapchat's AR/VR products. I'm an electrical engineer, and I lead the electrical engineering team that's working on the glasses. I don't know, they're glasses that are capture and display. And our team is responsible for integrating all the parts into the form factor, for working with the mechanical engineers, the industrial design engineers, the factory engineers, to make sure we have good test plans, to make sure that we validate the boards, and to make sure that things work as expected. For working with the mechanical engineers, the industrial design engineers.
Thank you all. And then just to preface, the format of this panel, we'll take questions from the chat, but we also have some questions that we've already planned for, so I'm going to start with those. So the first one is, how did you decide the engineering industry that was right for you? And then just whoever wants to speak can unmute. Questions that we've already planned for, so I'm going to start with those. So the first one,
I can start. So when I went to college, I went to Berkeley for undergrad, where the program there that I was in was electrical engineering and computer science. So it really kind of gave me the software and the hardware side of building things. And then I just kind of segued a lot. I sort of took classes that I thought were challenging and fun, and that led me into electrical engineering. I ended up pursuing it for a very long time. I got my PhD in it, and then after I started working in it, I really kind of realized that the depth of the electrical engineering I was doing was a little bit too deep for me. I really wanted to be a little bit more collaborative. I really wanted to work with the other teams. And then so 5 years after working at my first job at Texas Instruments, I switched over to Snapchat, where it's like a really good fit for me. I basically get to do technical work. I also get a lot of like understanding of how the electrical engineering team impacts the product design, and I've learned a lot about like LEDs from the optical engineers, a lot about displays from the display engineers. So I think I sort of took this very circuitous route, and just kind of like when it didn't feel right anymore, I would pivot and look for something that kind of fit my skill sets better. And so now I feel like I found a job that actually does really fit what I'm looking to do as an engineer.
Yeah, I'm happy to go next. I think for me, it was a long route into knowing that engineering was the right career for me. So I was lucky to have a dad early on who put this idea into my head that you would make a good engineer. And so going into college, I sort of put that as a major, but I still wasn't sure. I loved math and physics in high school, but I didn't really know what engineering as a career really meant. I think it took me a while to like, multiple internships of being like, oh, okay. And even now, like 10 years into my career, I'm so grateful that I kind of stuck it out at some points when I wasn't totally sure if this was the right thing for me, because I think it is a really great career, where it's really interesting work, where I'm always learning new things every day. So definitely, I think even if you don't feel like you're in middle school, high school, you don't know if engineering is for you, I think it's worth pursuing it a little bit further.
I knew I wanted to do engineering or suspected I wanted to do engineering when I was in high school, and I was inspired by my high school physics teacher who had us put together this Rube Goldberg contraption, and mine turned into a huge like backyard project. And so when applying to college, I didn't know what type of engineer. I was trying to figure out electrical versus mechanical, and I just picked mechanical because to me at the time it seemed more hands-on, which is what I was interested in. Um, Going into college, I just sort of stayed the course. Some courses were very difficult, and but you they progress and you learn and you get through it. I think my first math course in college, I my mind just failed and I blanked and I ended so there will be challenges, but you just keep on going. And so I graduated in mechanical engineering. And the nice thing about engineering, like Vicky mentioned, is there's a wide array of different types of roles that you can fulfill. You can be a analyst, you can be a hands-on building person, there's labs, there's project team leaders, there's a whole wide of types of roles that engineers can fill. And I've really loved my career. I've loved working with people. I've loved making really cool stuff, and so I'm very happy in engineering.
Thank you. And then kind of going off of that last question, what are your recommendations for a high school student looking to pursue like your specific field? And so like your answers will all vary based on that field.
Well, I can go first since I was talking earlier. The number one thing that helped me figure out what I wanted to do, which was harder when I was going to college than the opportunities available now, is I had internships. And I worked at different spots in the summer and realized that, okay, this type of field is not for me, and this type of field is. And so I was lucky enough when I was at college to have an internship working with space. We worked the KidSat program. We put a little camera on the space shuttle and took pictures, with coordinated of where we'd be over. And that just, I realized that that was something I really wanted to pursue. And that's how I also met some of the people working at Boeing and ended up going into the aerospace career. So I think number one, try out different work experiences. Things like FIRST Robotics is a great, wonderful opportunity because there's all types of engineering working together, and you can really get a feel for what you might really have a love for and a passion for. So FIRST Robotics, I think, is a great example of opportunity that's available.
Yeah, two things come to mind for me. If you, that's obviously, I think that's great if you have the opportunity to do that kind of internship. If you don't have that kind of opportunity, I think even just talking to people, like trying to set up informational interviews where maybe it's your parents' friends or, someone you found on LinkedIn who you're really interested in their role. I think just trying to set up some time to learn more about like what does the day-to-day job look like? What are you doing? Can help give you a lot of insight if you don't have the opportunity to do an internship. And then another thing for mechanical engineering specifically, I would say take things apart. Like if something's broken in your house, like open it up and see if you can figure out why. I think that is another thing to just kind of start to understand how things are working together, what design choices are being made. So just kind of look around, find what you have in your house and a screwdriver, and that you can actually find a lot of resources online. Like iFixit is a good one to see how to take things apart as well.
Yeah, I think for me, I would really recommend kind of echo what Molly said. Just get your hands dirty. Like I think a lot of us are engineers because it started out with liking to build and liking to, at least for me, it was very physical. I'm not a mechanical engineer, but it was very physical. I really liked being able to like have an idea and just like put things together. In terms of electrical, I think that's much easier nowadays. There's like Raspberry Pis, there's a bunch of tutorials, like anything you want to do, anything you want to monitor. You could probably find a tutorial and make like a quick little Raspberry Pi, like, program a Raspberry Pi and like do what you want to do. For example, like recently I wanted to have some sort of like water monitor for my plants. So like those things are just, they don't take a lot of time and they really kind of pique the interest. I think the second thing I would say is, and I think this is also something that is much probably easier to do now than when I was in about the same age, is look for peers who like to do the things you like to do. Like if you really want to learn how to code, I would, find friends who want to do it or go take a class somewhere. I took it at a community college when I was in high school. Or, just like any any way you can kind of get yourself into a community of people with similar interests. I think that that really helps because then you have this outlet to like talk about it and like push each other to explore more.
Thank you. Our next question is, can you do research as a high schooler and how? So like research maybe with a professor or something like
Uh, I'll start. We were just talking the other day at the startup I work at about looking for high schoolers to actually take things apart for us. So that could be one route. I can't speak as much to research in high school with a college, but maybe there are startups in your area who are just kind of looking for some potentially free or low cost help to do some stuff, and that could be really valuable to you as well.
Yeah, I would say I don't know of any specific resources to help, but I think just trying and kind of emailing is definitely a way. I know professors in different other departments, I can't speak for engineering specifically, will take high schoolers on who just send them an email and tell them their interests. I would encourage looking a little bit outside of the direct department. So if you want to do like electrical engineering, for example, you don't necessarily have to look specifically in electrical engineering. You could go look for like biomedical areas, like people who need engineering support, but may not necessarily need competency at like a graduate level where you're doing research, um, so I think I think it's worth a shot. I just personally don't know of a specific resource to do that at, but I would encourage you to do it if you're interested in it, to try.
Well, just to echo what Vicky said, I don't know of a specific route for a high schooler to get research, but I think that if you find something that you're interested in, just read about it, learn about it, and be passionate about it. And if you reach out to others who have similar interests, that they would probably be open to working with you. But I think as long as you know what you want to do, and there's many routes to go there, especially now with so much available online and a lot of different connections. So
that. Thank you. And then kind of related to research, I know that connections are really important for like getting a job. Um, so what is your advice on networking and going about getting those connections?
I think you just have to put yourself out there. Um, Again, if you're interested in something, try to learn more about it. Try to join clubs and organizations, and specifically things that have a goal where you can go hands-on. And there's many different organizations out there. If you're interested in robotics, there's First Robotics. If you're interested in other types of projects. There's a wide range of different opportunities there now. So I just, get your hands dirty and meet people in these areas that have the similar interests as you do. And you can help inspire each other and help each other out.
Yeah, I'm a big proponent of networking. Actually, my first job was via a college network. So I think my recommendation would be to explore what you might have around you that you might not even realize. So I didn't realize it, but my college had this sort of online network, and I was able to go through filter for alumni to see, I even filtered because I had been on the field hockey and lacrosse teams. So I filtered for people who had been on either of those teams and were in mechanical engineering. I'm working in San Francisco. And I set up an informational interview from that, was able to connect on, we had the same coach in college. And from that is how I got my first job at mechanical design firm. So definitely, explore what your school might have. Maybe that's more in college, but potentially through high school or other networks that you're already a part of.
And I think I would just say, like, in on a personal case, I think that that has definitely worked for me and is sort of responsible for me being able to pivot in my career. When I decided I wanted to leave integrated circuit design 6 years ago, I got the notion in my head I want to do something more consumer. I want to have it be more collaborative. And it might sound obnoxious, but I literally told everyone I met that this is what I wanted to do. And lo and behold, I was at a social function. I mentioned this to someone, gave them a little bit of my background, what I was interested in, and they were like, "Oh, Snapchat," which was purely a software company at the time, had started this hardware team, and he was like, like, you might be a great fit for this. And got an interview a week later, and then I got the job the week after that. So that's kind of an extreme case, but also not really, because I think a lot of times you make your intentions known. You there's something you're after, just talk to everyone you can, find the right groups, and you just don't know what opportunities are hidden, and people don't even know that, they don't know you're looking for it, so it's hard to match up. So you kind of put it out there, and good things can happen that way. So I'm a big fan of just networking as much as you can.
Thank you. And then we got our first question from the chat. So Joshua says, women are still the minority in STEM fields and are not very well represented to most FRC teams. Do you have any ideas how to recruit more young ladies to join FRC?
I think that there's no one way to do it, but there's many options. And I think panels like this that show that it is a good field, or here's some examples of women that have had a really good career and are happy in engineering. I think that also it's just getting the information out there, as far as trying to bring uh, engineering examples into schools at the early levels, which is what a lot of the STEM programs are starting now. It's just uh, making people aware, or making kids and young women aware of opportunities that are there, because some people think, oh, that's hard, that's not something I can do, and don't really realize that yes, it is. It is something that is very open to all people that are interested in science.
Yeah, I think another thing would be making sure that you're being welcoming when people do try to join. If you do see that you're starting to get people in, make sure you're kind of giving them activities and enough guidance without being overbearing. And then also taking a look and thinking about, maybe the women that are in your FRC group, and if are they happy? Because I think the happier they are and the more fun that they're having, the more they'll tell their friends, and it'll kind of perpetuate that way.
Yeah, I think this is a very tricky question. It's tricky for FRC. It's tricky even in industry, finding, I think, retaining women in engineering. And I think for me, when I kind of reflect on my career, I would say that the times I'm happiest are when I have good mentorship, or good, like a good partner with me working on something. So I feel like at the, for like an FRC kind of thing, I think it's possible to kind of also maybe look at it from that point of view. Like, can you, when you do find them, is it possible to kind of help guide that person? I don't know if mentorship's the right word, but just like really espouse the team part of it so that they feel included. They're challenged. And I think that for me personally has done a lot for me staying in this field, just having that connection with someone else, and knowing that like someone's there who has like my best interest at heart. So I think that might help with retention. I don't really have great advice for how to pull them in, because I think that's just a problem that we're tackling at all levels.
Right, thank you. Our next question: how do you overcome barriers presented to you as a woman engineer? It's like, I guess, okay.
My number one suggestion is just persistence. You are, every engineer, male or female, will run into problems. You are going to run into personalities that you might not work right away with. And it's just, don't let that stop you. There's always other ways. You can take the information and present it in a different way. You can talk to different people. Um, but I would just say be persistent, because there is a way forward. And, if you have a problem, find a good group of people that you can talk to bounce other ideas off of. There's this one person I worked with that, if you gave that person information verbally, it wouldn't sink in. But if you put it down on paper, the message would get across. So there's different things that you can try, but you just have to be persistent.
Yeah, Marianne, I would echo that. That was pretty much what I was thinking as well. I know early on in my career, there were some days when I would just feel frustrated. I don't know how to solve this problem. And I had to take a little bit of like a just show up kind of mentality sometimes. Like, okay, I just have to, I show up, I'm going to give it my all every day. And I think too, like reaching out to people, asking for help when you need it. Probably that, I think that was really hard for me, but I think you have to know that you're not the only person going through this. Every new engineer feels that way. So
So the question was, what what advice to as a female engineer? Was that the question?
Yeah, like how should you overcome any barriers presented to you on the job, if that makes sense?
Okay. Yeah, I think at least for me, I think for the most of my career, I've been focused on what I want, like on what I want to achieve, which is learning and growing. I want to get better at my job, and I want to be an asset to the team that I'm on. So I think I really focus on those things. And yeah, sometimes being a woman has presented challenges. But I think when that happens, one, I have a very good group of friends to vent to. And two, I really try to stay focused to what I'm trying to accomplish, and what I want to give to this team, or, to my goals. And that has helped me navigate that pretty well. I I don't know. I think part of me also really takes on the belief that I've been lucky. I haven't really been in a team that has been discriminatory. I really think that all the teams that I've been on, everyone really just wants to get their job done to the best of their ability. And if you kind of remember that, then you can. It's easier to reframe like what's going on in terms of like, am I helping that person also accomplish their team goals? Or it's kind of like asking yourself questions from different angles helps you kind of reframe where you might be. And somehow that has made it easier for me to kind of pursue and persist. Like Marianne always said.
And then our next question basically piggybacks off of this last one. So Aiden asks, what was a challenge you faced in engineering and how did you overcome that?
I don't know if that the question is what sort of like a technical challenge that you faced, or what is, just a environmental challenge of working with people. On technical challenges, you have things that fail. um, Sometimes your analysis doesn't come out like you want, or your test doesn't come out like what you want. And you have to just redirect. You have to dig down and find out why it didn't work, how you're going to get around, or redesign and things like that. Every not everything is successful, and so it's a little bit more of that persistence theory. You might have to dig down and find more details and learn more information, or if there's something, reach out to other people who might know more than you or have an experience in that field. um, in most engineering roles, you're not doing it on your own. There's a team of people that can work together and support you, and so that's one of the nice things that I've enjoyed working with engineering.
I can go next. I think the biggest challenge for me was really getting past my imposter syndrome. I think that I have I have almost been primarily the only female in all the teams that I've worked with, and I remember specifically after I graduated with my PhD, I got my first job, and I joined this team with like all guys. The first meeting I went to, they were like yelling at each other very loudly in this meeting about some technical problem. And I remember sitting in this meeting, kind of like cowering, like I couldn't say what I thought the answer might be to this. And that really kind of stayed with me for quite a few years, just like not being able to speak what I thought was, like it would be even hard for me to contribute to brainstorms because I felt like I shouldn't be here with them. Um, and yeah, it was just something I kind of had to deal with early on when I started working. And I think I started to get really past that once I realized that actually even these people don't really know the answer most of the time. And they also run into the same problem where they have a hard time asking for more clarification when they don't know what's going on. And that's just kind of a thing that everyone has. And I think when I made that realization, it became this point where like, now I'm the person in the room who like, I will just ask questions. If I don't understand something and they think they're explaining it to me well, like I sort of feel like it's also partly their responsibility to help me understand. So I'm going to ask as many questions as I need to understand what they're saying. And I think, yeah, just like kind of realizing that, that everyone's kind of in the same boat and some people have specialties and they know a lot about one thing, but since we are collaborating, it is kind of their responsibility to help me understand what they're trying to accomplish, kind of help me move past that imposter syndrome. And I think that that has been a very important step, at least personally for me, to feel like I'm more of a contributor in these teams.
Yeah, I think imposter syndrome was really big for me too. But just in case this person was asking more about like technical challenges, in case this is interesting, I'll delve into one that I worked on for a while. So I was working on a laptop, and we found that the speakers, we were part of my job earlier on in this project was to, optimize space for speakers. And I'd worked really hard to like challenge a lot of assumptions we were making about, how the enclosure was built and worked really hard to like carve out this space to get a really good big speaker driver in the laptop. And then as we started testing it in early builds, we realized that there was a lot of buzzing in the unit when we played the speakers. So, and it was, a months long, days on end in the lab to try to figure out why was this buzzing happening? Was it happening within the speaker? Was it something else? What exactly was it? It ended up being the keyboard, and then we had to delve into, even more months long. How do we fix that? Even though we understand why this is happening. And again, I think this is probably echoing something that Vicky said before, which was, just having that team that you're working with. So I had, 2 or 3 people who were in the lab there with me every day. There were times when we felt like we were just like hitting our head into the wall, like nothing's working. But then we would just kind of like sit down, logically think through, okay, what's XYZ? What do we need to do to figure out, root cause exactly what's happening here? And so I think had I had to do that alone, that would have been a really, really painful series of months. But working on that problem with the team, it was honestly like a really fun effort. I still, keep in touch with those people today, and I think we got really close through that process. So yeah.
Thank you. And then our next question, kind of going on the technical side of things, is how creative is your work and how much hands-on build/prototype work do you do? I know this was touched on a little bit, but if you guys could expand, that would be great.
I can start. So I work on a hardware team. Snapchat Spectacles is not wildly sold. It's kind of a low volume product as we're trying to figure out what the core product value is to consumers. So as a result, we don't go through the entire consumer design process, and because of that, I would say my job is very like I'd say we basically do like prototype / early engineering. So we build things into units. They do have to work at like, a low volume kind of reliability working. But a lot of it is we move very fast. We probably put out a new product every like year and a half. So if you imagine, we're going from like a development platform which is like a big board, to fitting it into kind of an eyewear unit. And we're cramming like cameras in, displays in, every generation we put a new sensor in. So there's like an altimeter, a capacitive touch sensor, a proximity sensor. So every new thing that we do makes it so that there's a lot of engineering that goes into it. And as a result, a lot of issues that come up with it, like a capacitive touch sensor seems very easy because we're so used to it on our phones. But when you're putting it into like a tiny eyewear product where like, your hair can kind of blow around, or you're outside in the wind and you can set it off, it really becomes like a engineering, I won't say challenge, but, problem to solve, and, how to make this product reliable and actually reflect the environment it's in, so it's not false triggering. So yeah, for me personally, I do a ton of lab work. I would say half of my time is lab work / validation, where I'm actually like measuring stuff. And then half of my time is spent kind of project managing my team to reach our deliverables.
I'll go next. It really depends on the project, or the program that I'm working on. Most of the programs that I've worked on have been larger programs, and so there's a lot of engineering by computer. So you do a lot of analysis and design drawings and stuff like that. But I'm not out there in the machine shop usually making the part. I'm working with other people who are doing that. Most of the hands-on experience I've had has been in development testing at Boeing labs for different projects at a smaller scale, where you test things at a subscale and see if it's works as you expect, and so it can go off into the bigger scale, or working with other people who are doing the tests or manufacturing the part. So a lot just in my role has been if I'd split it, it'd be like 75% not hands-on, depending on what project you're on, and maybe 25% actually supporting tests or something like that. But it varies based on what I'm working on.
Yeah, I was going to say a similar breakup in my job today of probably about 20 or 25% hands-on prototyping kind of work. I've definitely done a lot of prototyping through my career, a lot of 3D printing, laser cutting, assembling prototypes, testing. Today, I think a lot more of my there's definitely still a lot of creativity though in my role. And I would say a lot more of it is sort of strategic thinking. My role is gone a little bit away from engineering and more with working with customers. So sometimes that strategic thinking is, how do we win this customer back? What are they unhappy with? And how do we change that situation so that they're happier customers? Some of it lately has been, supply chain related issues. So we can't get this camera that we're used to working with. What are our alternatives, and how can we source something else that will still work? So I think there's creative thinking every day. It maybe doesn't always come for me in the forms of hands-on prototyping, but it has been a big part of my career.
Yeah, and just one add-on to what Molly said. A lot of the fun projects that I started out on were we have this problem, or we want to do X, Y, or Z. How do we go about it? And it's the creative thinking of there's a bunch of different ways we can do it. What are the pros and cons? And you can come up with again, working with a team, um, coming up with a solution even before you're actually touching any hardware. So that's sort of the fun part too.
Our next question is, how much of your college education applied to your careers? And are you doing what you thought you'd be doing when you were in college? And what did you think you'd be doing in engineering? So I know that's a bit loaded. I can repeat it if you'd like.
I think I can at least give it a start. So yeah, I would say probably in engineering more so than other fields. A lot of what you do learn in college, I do feel like I'm actually using. There definitely were a lot of, for me, I remember doing a lot of like differential equations in college that I haven't even touched or looked at since. But there definitely were a lot of, I mean, even high school classes, even like, high school physics, trigonometry, I find myself doing. So yeah, I think a lot of the classes do apply, but I think also part of what I learned is that you need to know where to go to solve problems, and it's more about being a problem solver than like root memorization from college classes. So yeah, trying to remember what the second part of that question was. You guys can go if you remember.
Just when I was in college, I wasn't quite sure what I would be doing as an engineer. So I really didn't have, I think one of the part of the question was, did you end up doing what you think it was? I really didn't have a clear clue as to what my eventual career would be. So there's not really a go back on that. Um, but as far as how much of what I learned in college is directly applicable, so mechanical engineering, you get a wide broad of, sweat of classes. You have, materials and fluids and heat, and you get a very wide understanding. And then when I hired into the fuel cells and cryogenic fuels group, which was nothing that I learned in college. It was very specialty topics and how to handle it. So I could apply some of the basics. Here's my heat transfer, but the vast majority of the tools and the understanding that I ended up using was developed on the job.
So I think for me, it depends on the stage. When I graduated from my PhD, I worked at a job where I really could not have done that job had I not gone to school for so many years. I think now what I do, I would say that it is still directly applicable. I think the biggest thing for me, and partly based off where this, like how long I've been doing this, is more like the things that I learned in college makes me know what the possible knobs to turn are. So, like for example, right now I'm working on an issue where we're trying to like understand a transmission line problem, which is effectively like, how do you make a channel for a radio frequency signal? I can't remember every single thing I learned from college, but I remember like generally the basics, and I remember like we need to test it this vague way, and then I have to go on the internet and kind of look up what I'm doing. But I have the fundamental kind of like is in my head, so I know what issues to look for, even though I may not be the most adept at pulling up that knowledge to solve that problem on the spot, if that makes sense. And I think that it the stuff you learn in college is very helpful to help you solve problems, because you know you have an idea of the keys and the fact like the knobs you can turn, and without that knowledge you're kind of limited on how creative you can be, right? um yeah.
Yeah, it's almost like you practice solving a lot of problems in college, and you might not be solving the exact same problems when you get to your career, but you sort of know the strategies, so they still apply.
Thank you. And then we got a question from the chat. So Aiden asks, in your opinion, what is an important step in writing code or creating a mechanism that is often overlooked or not seen as necessary to do?
I would say early on defining the requirements. So I think like what are you hoping to do with this, and sort of laying out like what are the goals, what assumptions are you making at the start. I think that's probably often overlooked and often important in actually uh, executing something that works well.
I think for me, it's documentation, specifically for code, but even just for like engineering problems. I can't tell you how many times I've like done a difficult debug or solved a difficult problem that I think I don't need to document because I will remember this forever because I spent so many months doing it. And then honestly, like a year later, you completely forgot everything, and you're like, oh, I remember we looked at this vaguely and we tried this, but I don't remember the result. Um, so definitely is something that like for my team, I'm very like we need to document. I don't it may seem trivial at the point when you're doing it, but having that to reflect back on and like refresh your memory and make it so that you don't have to go through all the same experiments again when you're solving a similar problem is life changing.
I think the question was actually, could you repeat the question, please?
Yeah.
This one.
Um, what is an important step in writing code or creating a mechanism that is often overlooked or not seen as necessary to do?
Okay, thank you. I just want to make sure my answer was applicable. One thing that I learned early on and got burned by, and is that when someone comes to you and says we have to do, something, and here's, what we've done in the past, or here's why we're doing it. It's always good to go back and look and verify that actually that's the case. So, people sometimes have remember things, and they'll remember it slightly different, or they'll assume some code or regulation is in place. And when you go and you read the text, you realize, well, actually, it doesn't quite apply the same way. So to just go back and check your baseline assumptions against what has been documented, and make sure that from the get-go you're aligned with what what the expectations are, or what the assumptions are.
Thank you. And then our next question from the chat is, what are your typical team sizes and what other disciplines are represented?
It depends on the program. Some of my teams are very large, but then they're broken down into subsystems, where the teams, are somewhere between 10 and 5, because I've been working on development programs. And those teams are, engineering, of course, project management, schedule management, and the unsung heroes is like supplier management and the people that make purchasing and happen. And so that's generally the sizes that we've been working for. And again, many are part of larger teams, but that's sort of the functional team that I work with.
Yeah, mine is about the same size. I think all the teams that the ones where like I kind of really know what they're working on day to day would be somewhere in the 3 to 7 range. Um, on a larger scale, to do something like Snapchat Spectacles, we do work with all disciplines, engineering disciplines. I think to add to what Marianne said, we have all those teams. We have like a CMF team, which is the industrial design that does like the color, material finishes. We have a product team that we have to work with. We have a UX team that we have to work with. Different teams will set different goals for the product. And I think for us, maybe that's somewhere in like the, I don't know, 80 to 100 range right now.
Yeah, instrumental. Today I work on a team of 5 people in the solutions team. And so we're 4 mechanical engineers and 1 software engineer who kind of help do the technical portion of scoping and implementation. But we, are working every day with people on the operations side who actually deploy our cameras on production lines. And we work with the sales team. That's another like 5 or so people. So yeah, being able to work cross-functionally, I'd say is pretty huge, but probably a little bit smaller for me than these guys on the team sizes.
Our next question is, what are the must-have skills needed for your profession?
I would think that the number one must have is being able to try to figure out and look up information on your own. Um, there's problems that you're going to run into, no one's going to know the answer for. You have to learn how to research, how to educate yourself on that. And, you know, because the answer is not necessarily out there. So that would, being curious and being able to educate yourself on new situations that arise.
I would say for me, I feel like being detail oriented and being able to communicate your ideas are probably 2 of the most important. I think things are often overlooked, a decimal place is missed, and so those kind of things is really the detail oriented. But if you can't communicate your ideas to the rest of the team, then nothing will get done either.
I agree with those two. I'd say for me, it's also probably being systematic. So understanding, kind of speaking towards like a debug goal, like understanding how you're setting up the experiments, what you hope to get, and kind of like methodically walking through that is important. I think sometimes, especially when you start and you're presented this problem that you don't know, it's easy to just kind of like have a ton of thoughts and not really sure how all these thoughts are going to come together to get you the result that you're looking for. So making sure that you know your inputs and are asking the right questions along the way has been helpful for me.
Next we have, what is your work week like? And is it long hours, like more than 40 a week?
Oh, sorry, you want to go?
No.
Okay. I would say for me, it probably ranges between 40 and 50 hours a week. So not crazy. Sometimes 50 hours can feel like a lot, but I think it's a pretty reasonable place to be. Work week. Today I spent a lot of time in meetings. So probably at least half my day every day is spending in meetings, and then trying to kind of get my individual work done outside of those meetings. And I normally work like, just to give you an idea, like 9 to 6 or 7, probably those kind of hours.
I was just going to say that it's varied over my career, and depending on the program I had, some programs we had to get something done, or if we're doing testing, you're working long hours. And then other times, on average, it's been 40 hours a week. One thing that I've been very happy to work at Boeing for is that when I ended up having my kids, I went part time, and they were very flexible with me and allowing me to do that. So again, it depends where you work and what aspect of the program you're working on.
Yeah, I'm also the same. I think I've definitely pulled all-nighters for work. I've also definitely like right now I'm kind of in a slower period, so I probably work 30 hours a week. I think it depends on what project you're on, what phase of the project you're on. I have to travel for work sometimes, so when I do travel for work, those tend to be very long weeks where at the factory, like all day, just sometimes working and sometimes waiting for things. Um, but I've also been very fortunate everywhere I've been. They've been very understanding that, the balance, and they've been very flexible. I've also gone part-time for a while. I've also, um, you know, I've also like now with work from home, it's a lot more flexible, I would say. So I can, I really can work my other responsibilities into the workday, as long as I'm not in the critical path.
Thank you. And then we have a couple questions from the chat. Our first one is from Joshua. How large of a factor was the workplace culture in deciding where to work? So for example, if you had to decide between two places, where the first place has projects you're very passionate about, but the second one has a better culture, what would be your decision?
That's a hard one. um, when I first started working, I didn't realize how much of an impact the people I work with will make on how happy, how easy it is to work. And so I was lucky that I really came into a good working environment, um, and coupled with the fact of an area that I was passionate about and I really liked. So I was lucky in that. But looking at other people across the board, I think maybe not necessarily, I wouldn't say culture, but uh, the uh, the openness and the willingness for a team to work together is extremely important. If you have a group of people that respect each other and are open to listening to each other, that makes your life and your program and your projects go so much better. And if you don't have that, you can be miserable. So I could be working on something really a great project, and if the people that I'm working with are not conducive to really having a good working environment, it can be a very tough thing. So I think not necessarily the culture, because I've worked with really old school cultures, if you will, but the people really work together, and that's what's important. Is if your team is respectful of each other and can work together, that's can make or break your job, if you will.
Yeah, I think I'll just piggyback on that. I feel exactly the same way. I think it's a very hard question to ask, especially when you're interviewing. You don't really get a You can kind of look up what the work culture is like, but in my experience, the general work culture that people feel, especially about the large companies, really has no relation to how your individual team is going to be. And like Marianne, I think I've been successful everywhere I've worked because I have had such an amazing team. And I don't want to say they define the culture, but they just are people who are like great to work with. We have the same goals. They care about their jobs. They're putting in the time. They're respectful. There's not a lot of like ego boosting on the team, which is something that can kind of get in the way sometimes. So I think if I were every time I interview personally, I don't really look at necessarily what the company culture is, even though there is some trickle down effect from that. But for how long, what really matters to me is what the the team culture of the specific team I'm joining is like, because I do think that that affects your day to day, and that's where like the energy can really get sucked out of you, or it can really rejuvenate you because you're on such a great team.
Yeah, I totally agree with what you guys both said. I think for me, it's way more about the people than the content of the work, honestly. So, if faced with that decision, I would probably choose the one where I felt like the people, the teamwork was a better working environment.
Thank you. And then this is our last question. Sorry we didn't get to all of the ones in the chat, but what are your aspirations for the future in your career?
Yeah, that's a tough question. One that I've been struggling with myself a little bit. But I think what I've realized is that I'm just happiest when I am, working on really tough technical problems. And so I just want to keep putting myself in positions where I'm learning something new all the time. And yeah, I think I've been trying to work on sort of defining like what do I want to be 5 years out, 10 years out, and I think the reality is that it's probably going to be more of a see what opportunities arise, and just keep making sure that I'm working on something all the time that I'm enjoying doing.
Yeah, I'll just second what Molly said that I really I enjoy working on projects and solving problems and having that project successfully launch into space or develop into a new component. That's what I enjoy. So as far as I'm not trying to be a CEO of a company or something like that and go the management path. I really think I'm going to stay technical and continue working on challenging projects.
I think to add to that, I think I'm in the same boat as them. And I will say that's probably one challenge that presents itself in industry. Sometimes it's very difficult in companies to continue developing on an individual contributor technical track. There are companies that do this well, but I think a lot of companies don't necessarily do that. And I think after you work for 5 or 10 years, you really get this impression that the only way to continue your career is to move into management. So for me personally, I really struggle with this because I kind of am like these gals, like I really like the technical stuff. I get a lot out of it. And it's to the point where like sometimes when I'm in it, I'll be like, oh, I'm so tired. I want to do something else. And then once it ends, I'm like, I get a little bit of FOMO, like, oh my gosh, I'm not on the next project. So I think, yeah, I think I'm sort of like Molly. I put myself out there. I know what I like and what I don't like. And I'm going to just see what opportunities come up and pick the one that aligns best with what I want to do, and try to not think so much about what I should be doing, but more like what I actually want to do.
Thank you all so much. Thank you to everyone that tuned in. We'll be planning another panel or two in the new year, and we'd love to hear from you all about this panel, and where you're from, what your interests are, and whatnot. So please go to our Instagram, and refer to that post. But yeah, thank you so much. Thank you again, panelists, and see you guys later.